Hi, guys. All right. Let me try and use this one here. Hello. All right. Hi, I'm Mark Jakewith. I'm one of the lead developers for WordPress core. And I'm here to talk to you about secure coding with WordPress. How many plugin developers are here? Anyone who's written a plugin? Cool. And theme developers? Great. What I'm going to say is going to apply equally to both of you. I may say plugin, but when you hear that, I mean, the WordPress plugins today are, the WordPress themes of today are pretty much like plugins in what they can do. You know, with functions.php, you can do just about anything. So when I say plugin, think plugin and themes. So I give this talk a lot. I've been doing this for a few years. And so what is the state of WordPress plugin security? Who here thinks that they are very confident that the plugins or themes they write are secure? Hey, 2 hands. Maybe 1.5. Oh, Daryl. There you go. Yeah. Okay. In general, yeah. Not a good situation. All right. So I don't mean to pick on you, but there's cross-site scripting in shrimp test. Didn't take long. So you're obviously a very smart guy. It has nothing to do with intelligence here. It's definitely an issue, I think, number one, of awareness. They're not really hard problems to solve, just most people aren't aware of them. So that's why I do this. The second problem, in some cases, is apathy. Some developers just don't care. They don't care about sort of the damage that could be done, or they view the possibility of their code being compromised as remote and not worth their time. So this is a little bit more problematic to me, even maybe unethical. Sort of like an engineer, when you build a structure, you have to make sure that it is sound. It's not going to collapse on people. And I do a lot of cleaning up after hacking incidents, and the damage can be considerable, and the cleanup costs can be quite high. So my goals for this talk, I want you to learn how to thwart the 3 most common attacks. I'm going to teach you 2 useful principles, and then give you some common mistakes to avoid. Number 1 is SQL injection. SQL injection is probably one of the more serious dangers because it gives them access to your database, and once they're in there, they can do all tons of stuff. And it often happens that these are remotely exploitable, which means it can be exploited without tricking a user into doing something. It means someone could write a script to go out and hit a bunch of WordPress blogs. So the damage to this can spread very rapidly. So here is a normal or a manual update query. We're updating the post table, and we're setting the post title where a certain condition is matched.
You have to speak up, man. We can't hear you.
All righty. How's this? Better? All right. The danger points here are new title and my ID. New title has to be wary of single quotes. If that value has a single quote, you could sort of jump out of that and start inserting other SQL statements. And then my ID is sort of assumed here that it's going to be an integer, but you have to make sure that is actually the case. So how should you handle this, and how should you sanitize this? Well, you shouldn't actually be doing a direct query for most things. You should be using the WordPress API. So for something like this, you'd use WP update post. So if you stick with the API functions, you're going to save yourself a lot of trouble because those all take care of that for you. But pretend that's not available. So WordPress database class has a really handy method called update. It takes advantage of the fact that most update queries are pretty simple and are of the form update table, set foo equals bar, where x equals y. And it looks like this. It takes 3 arguments. It takes the table you're updating, a named array of the updated columns, and a named array of the conditions. So you sort of read through this like the SQL statement, update posts, set post title equals new title, where ID equals my ID. And this takes care of all escaping for you, so you don't need to think about it. You pass it in raw. And you can also update multiple columns, and you can set multiple conditions which will be joined together with an AND. And if you're inserting data, there's a similar method. It's the only difference is it only has 2 parameters. It takes a table and then data, which is the named array of columns. What if you have like a select, which we don't have a simple API for, or a more complex update that can't be handled? We have a method called prepare. Prepare is a sprintf powered MySQL query constructor. And it looks like this. So you give it 2 or more arguments. The first is the query with little placeholders, little tokens there, and then the subsequent arguments are in order the tokens you use. So some name corresponds to %s and some ID to %d. So the syntax should look familiar. This is sprintf, but we're only supporting string and integer, S and D, so you can't use the other ones as of right now. And you don't have to quote S, you just use it raw. And this does all the escaping for you. So that brings us to our first principle, which is to escape late. What I mean by that is when you do your escaping, you should do it as close to the vulnerability point, or the potential vulnerability point, as possible. If you escape much before that, you're likely to lose track of what's been escaped and what's not been. When people are auditing your code, they're going to have a hard time figuring out what's safe and what's not. So right before you do the query, you do the prepare. In fact, I usually just wrap it. So whatever the query method I'm using, inside that I have the prepare. So it just gets escaped on the fly right there when it's needed. The reason you do that, another reason, is that there's really no such thing as escaping generally. There's only escaping in a certain context. So this way you keep all your data pure until you're ready to escape it for a specific context. XSS, cross-site scripting, is definitely the most common vulnerability. That's the one I got on Shrimp Test. The idea here is that a malicious party tricks you into executing malicious JavaScript in your browser, which allows them to control your browser. And they can leverage that into further attacks. So this would be a super simple example where we're echoing out this title variable. We don't know that title is safe. Title could contain something like this, in which case it's just going to execute in the browser as soon as the page is loaded. It doesn't really matter what the payload here is. That's why I haven't shown you a real example of what they do with it, because it doesn't really matter. If they can execute JavaScript, they can do anything the current user can do. So if the current user account can edit themes, then they can edit your theme and insert malicious PHP, and that's game over. Rule number 2, anything that isn't hard-coded is suspect. And actually, a better rule, since it's hard to keep track of what's been hard-coded and what's not been, just mistrust everything. So, so maybe you had a string that was hard-coded in version 1, but then you add the ability for users to update that in version 2, and if it wasn't escaped in version 1, you might forget to do it when you update, and bam. So if you just do it all the time, you'll be covered. So even in WordPress core, we do a lot of escaping of things that we know are safe because it's just a string right there. We do it just to cover our bases. So cross-site scripting, easy as 1, 2, 3. So as of WordPress 2.8, we have a really easy to remember group of escaping functions. They all begin with ESC for escape and then underscore. That's number 1. And then number 2 is the context that you're escaping for. So right here, ATTR means attribute, and that means an XML or HTML attribute. So value equals, quotes, and then you're echoing something out there. That would be an attribute context. You can also pass here HTML, URL, or URL raw, and we'll go through those. The suffix, number 3, is optional. It's just a way of doing translation and escaping in one go. So we found that a lot of times we had to do, use the WordPress translation functions, and then we were escaping something. So we thought, why not give the ability to tack that on to the end? But we're just going to focus on parts 1 and 2 here. So in a basic HTML context, which was like what we saw before in the H1 tags, escape HTML is the way to go. So this is essentially PHP's HTML special characters function, except that it doesn't double entity encode. So for example, if you have something like ampersand LT, semicolon, it won't become ampersand AMP, semicolon, LT, semicolon. It'll prevent it from doing that. So here's how we'd make that H1 example safe. Pretty simple. What about this situation? This is now within an HTML element attribute. We have a title there we're echoing out. So we're not just worried about angle brackets, like in this case here. We're worried about quotes. Just like with the SQL example, we don't want them to jump out of the current attribute and then start doing their own. So in this case, I have some exploit code here that's adding an on mouse over. So you can see how they could inject scripting functionality with that. So we have escape attribute. So this will additionally encode the quotes so you can't jump out. And that's it in practice. This is really simple stuff. You just need to know it. All right. Let's revisit that example, except now we're echoing out into an href. So now, you see in that exploit, there are no quotes, there are no angle brackets. It's just using the sort of, what do you call it, pseudo protocol for JavaScript. So we need to protect against that specifically. And we use escape URL for that. That just takes a URL. It makes sure that it's clean. It's using one of a whitelist of protocols. JavaScript, not one of them. Cleans it up. It does the ampersand encoding for you. So if you have a query string and you have an ampersand, it'll change it into ampersand AMP, so your HTML is valid. And if you need to ensure something is a valid URL, but you're not outputting it to HTML, say you're saving to the database or doing a redirect, you don't want those encoded ampersands, so use the raw version. And escape.js is used when you're using PHP to echo values into JavaScript, like this. So you might be doing this up in the head, setting an ID or setting an AJAX handler URL, something like that. And this handles it in the JavaScript context. And lastly, we have escape text area, which should be used inside text areas, and that does double encode entities, which is what you want when you have a text area where you might be editing HTML. You want those ampersands to be maintained on save. So the problem with escape HTML is that it kills HTML. So what if you want people to be allowed to use some HTML, some safe HTML? For example, widgets have this problem a lot. They use like a text widget. You want them to be able to use things like links and bold and not kill all that HTML. You don't want them to use scripts. So we have this function, WP filter cases. Cases is our HTML sanitization library. We have a whitelist of HTML that is available to people of various accounts. So if you're an author, you'll have a certain level. If you're an administrator with unfiltered HTML, you can pretty much do anything. So this will take the current user into account. This is sort of an expensive function to run. It does a lot of work, so you should really do this on save. So if you have a widget and you're updating it, don't do this on every page load. Do it when you save, and then save that version. And the third type of attack is CSRF, which is actually pronounced CSRF. Actually, I only learned that recently. This is lower severity than cross-site scripting in most cases, because it usually doesn't result in complete access to anything. So this is sort of a tricky issue to understand. A lot of people think they understand it, and then they propose solutions that are inadequate because they're not really getting it. So the issue here is the difference between authorization and intention. Authorization is what you're allowed to do, what your user level, what your capabilities are. And intention is what you fully want or mean to do. So for example, RFID is sort of susceptible to intention attacks. Say if you have a door here that is triggered by RFID, they have a little box on the wall. If you could trick someone with a valid RFID card into getting close enough to that door, you could have them unwittingly unlock it. So that's sort of what happens with CSRF attacks, is that the attacker sort of tricks you into submitting an action on WordPress without your knowledge or consent. And because you're authorized, WordPress says, okay, fine. So we need some way to make sure that you can't be sort of tricked into submitting a form that deletes a post or something like that. So we handle this with nonces, which is an abbreviation of number used once. What we use are not technically nonces because we don't use them once, we use them over a time period. So these are secret keys that are specific to the action, to the object, to the user, and to a time frame. So say I'm deleting post number 2. The nonce that I would use would be specific to me, user X. It'd be specific to the action of deleting a post, and it'd be specific to the actual post I was deleting. And it would only be valid for, I think it's 24 to 36 hours. Oh, and don't ever, this means something else in the UK and Australia. So don't call someone this, no. Look it up later. All right, so yeah, covered that. So the way you do this, it is primarily used in forms when you're saving something, because most actions are sort of idempotent are done in forms. You just use this function and you pass it in a string here. The user context is already taken care of you. We're just taking care of the action and the objects here. So this string can be anything, but it should be fairly unique. So as a plugin or theme author, I would have like your plugin or theme name, dash the action, like update settings, and if it's something that has an object, like you're updating a post or something like that, add that to the end like that. So there it is in a form. You can stick it anywhere in the form. And on the back end, when you are about to perform the action, whatever it is, call this, and then pass in the same exact string that you had here. So those need to match up. And if the nonce does not match, they won't be able to do it. They'll get, you're not allowed to do that message. And you shouldn't just run this on every load. You should make sure this is limited to the update. So wherever in your code you have like update option or something like that, this would go right before that. This does not replace authorization. This is used hand in hand with authorization. So you still need to use current user can, use the capability system, make sure they're allowed to do it. So this the two things. They're allowed to do it and they mean to do it. You also have to worry about CSRF for AJAX or XHR requests. And you do that like this. WP create nonce, same thing, pass in the unique string there. And then you stick it onto your AJAX request with underscore AJAX underscore nonce equals what you just created. Pass that in. And on the back end, check AJAX refer. Same sort of deal. All right. Here's the mistakes that all of you are probably making. Who here is an omniscient being? All right, settled. None of you can use this ever. Eval is evil, and you should not use it. I think we've almost gotten rid of it in WordPress. If you don't know what this is, good. Don't learn. This one I see all the time. Who here thinks this is fine? It's not. So server variables are not safe. Just because the server is generating, you can't assume that they're just safe to echo out like this. Request URI is a common one. PHP self, not safe. So don't forget to escape these. So what should I use in this case to escape? Escape attribute. You could use escape URL too, because it is a URL, but in this case, I'm not aware of any JavaScript vulnerabilities through form action, but it wouldn't hurt. So one of those two. All right. Quiz time. How should I make this safe? All right, do the first one, or? Oh, sure. Yeah. So the question is, how do I know my developer knows this stuff? You don't really, but so a lot of what I do is actually auditing other people's code. So sometimes they'll have a junior level developer code it, and then they'll hand it over to me, and I'll just breeze through it and then fix the issues, and then send them back to the developer so that they can do better next time. So that might be a more cost-effective way, cheaper than having me develop the whole plugin. All right, who can make this safe? How about home? Come on. Escape URL. How about title? Escape attribute. How about text? Escape HTML or WP filter cases. And escape JS. See, it's simple. Yep, just like that. All right, let's do questions. Yay. So how do you know a plugin is safe? So not something you're having developed, but something like in the repository. Most of them are not safe. If you do good backups, yeah, WordPress. I know some people here can hook you up with that. But if you're actually looking for them, the common ones are, if you're looking to looking to fix them, you look for things like value equals. That's the common one. That's how I found the one in shrimp test. You look for value equals, and they're not doing the context sensitive escaping there. You can try, so like the way I actually did it was in shrimp test. Oop, there it is. Two of them. Twofer. What I did was I just did like that. Yeah, that's exactly what I did. So what's happening here, I didn't even have to look at the code to do this, but I'm assuming it's doing value equals and then double quotes and then it's echoing it out. So I'm doing a double quote to sort of jump out of that value equals, then I'm doing a script right there. So yeah, so after save, that would echo or alert the cookie. So you can test forms by form fields by doing that. That's a good way to find XSS.
I'm fixing it now.
Yay! Worth the trip.
You can't trust yourself to not type in script in there. I mean, who can you trust? That's the
Oh,
question.
okay. So, well,
I mean, shouldn't no one have to worry about like other users who could potentially type something in like comments?
right. Yeah. So, with cross-site scripting, especially in the admin, I'd be ultra paranoid. Now, it's true that like if you have unfiltered HTML, you could do a script tag and a post, right? The front end is less of a concern because there's cookie separation between the front end and the admin. In the admin, we take like a zero tolerance approach. So even if it's you shooting yourself in the foot, so it's possible that this could only be done by me. It's also possible that you could use CSRF to say, I don't know if that's being protected by a nonce. So if someone just sort of downloads this plugin, sort of copies the form, changes the post to my server with that cross-site scripting in there, and then I visit their malicious site and sort of in an iframe it submits that out, that could do it. So I did it. It's the whole intent.